Hi everybody, today we're going to start Unit 10, right triangles. The first section is to make us remember the Pythagorean Theorem, okay? And a couple of applications of the Pythagorean Theorem that we hadn't done before, okay? So these notes are on your Google Classroom, a blank copy, okay? So feel free to print them out and then follow along as we do them up here. If you don't have access to a printer, no problem, just got to jot down some notes on a separate piece of paper. Okay, it's definitely beneficial though to take notes however you have to, because you will be able to use them on our Google Classroom quizzes. Okay, so our very first section of notes here, more applications of the Pythagorean Theorem. And our first type of problem are vector problems. So with a vector, it is simply a quantity having direction and magnitude. So just to clarify what that means, okay, basically this thought bubble over here tells you that a vector is represented by a ray. So if we drew a ray, but we were really concerned with the direction we drew it in, north, east, south, west, or the magnitude, for example, like distance or speed, or maybe it represents force, that would be what we would consider a vector. So just to remember, guys, north, south, east, west, you will have to know your directions. And then as far as magnitude is concerned, we're going to really focus on distance. However, you do vectors in physics, so if you plan on taking a physics class in the future, you may deal with vectors that have speed and force, so this is a really good section to know. So how I'm going to need you to do it for our class is basically to draw pictures that will end up being right triangles, and then you'll have to solve for one of the missing sides. So for number one, it says here that David left his house and rode his bike 5 miles due east to meet up with Jacob. And then from there, they traveled together 2 miles due south to McDonald's. So basically what's happening here is that David starts right here. I'm going to put D for David. And he travels 5 miles due east, which remember is going to the right. And that is 5 miles. So I'm just going to label that with a 5. So basically that's a vector because I mentioned that it's got to go due east, which is to the right, and it's got a 5 on it representing the number of miles. Now from there, so from this point where he ended, he now went 2 miles due south with Jacob so they could go to McDonald's. So due south means straight down. Now it doesn't really make a difference how big I make this vector, but I know that 2 is smaller than 5, so I just made it shorter. But in all honesty, guys, it really doesn't make a difference. What makes a difference though is that you're attempting to draw this as straight as possible, so you recognize that this turn makes a 90-degree angle. And if I were to just connect this end with this end of this arrow here, notice that I've made a right triangle. Therefore, this is why I'm using the Pythagorean Theorem. In fact, part B will tell you exactly what they want you to find. Find the distance from David's house, which remember we said was right here, to McDonald's, which is where they ended, right here. So they just want us to find this side right here. And I'm just going to put an X just generically, because that's usually what we use for our unknown values. Because it's a right triangle, I can use the Pythagorean Theorem. Remember, the Pythagorean Theorem is a squared plus b squared equals c squared. And if you remember, the a and the b are what we call the legs of the triangle. They're just the sides that make up the 90 degrees. And this right here, we call the hypotenuse. The hypotenuse is always the side that's across from the 90-degree angle. So if you notice that we put that little box here for the 90 degrees, that corner literally points to the side that's the hypotenuse. So this right here is our hypotenuse. So since that's the side that we're looking to solve for, We're just going to go ahead and plug in the 5 and the 2 in for A and B. So that's 5 squared plus 2 squared equals x squared. And we're going to solve for that x, which is this hypotenuse right here, and that will give us our answer. So 5 squared is 25 plus 2 squared, which is 4. Then putting those together, that'll give us 29 equals x squared. Now to get rid of that square, we're going to square root both sides. And we do that on our calculator. This is my calculator, you just can't see the details. Okay, in the directions it had said to round to the nearest hundredths, which is 2 decimal places. Okay, on my calculator, I end up getting 5.38516. Okay, well, if I want 2 decimal places, that means 2 numbers after the decimal point. But don't forget to take a look behind at the 3rd number. 4 below, let it go. 5 or above, give it a shove, right? So this is actually going to bump up to 5.39. So that's 5.39 miles, okay, for that value of x right there. And that kind of makes sense, all right? We knew that it had to be bigger than any one of these 2 sides because the hypotenuse is always the biggest length in all 3 sides of the triangle. And at the same time too, if you do try to draw it as accurately as possible, then you can check the reasonableness of this answer. Kind of based on how we drew it, kind of makes sense that that length of x is just a little bit more than 5, but not too much more. All right, let's do one more example with that. Okay, if we move on to the next problem. Okay, now we're talking about Little Red Riding Hood. All right, so Little Red Riding Hood leaves her house and drove due south 24 miles. She then turned and drove due west to reach her grandmother's house. Notice that they didn't give us miles there. They just say due west. The direct distance from Red's house to her grandmother's house is 25 miles. All right, so let's draw a picture of this, make sure we can wrap our mind around what's going on here. All right, so Little Red Riding Hood left her house and drove due south. So remember that due south means straight down. And we know that is 24 miles, okay? From there, she turned and drove due west. So remember that, according to our directions, west should be going straight to the left. Okay, now I don't know how long that is, so, I don't know if this is accurate or not. Well, they don't tell me where to go, okay? So I just go ahead and draw there, just leave it go. And now they talk about the direct distance from Red's house, which is where she started, to her grandmother's house. So basically they're telling us that from here to here, it is 25 miles. So this one's a little different because now they gave us one of our vectors and they told us that direct distance, but they don't tell us this mileage here. However, though, because this is due south and due west, we do know it makes that 90-degree angle. So we do have a right triangle and we can again just use the Pythagorean theorem. So how many miles did Red drive due west? That's this part right here. And let's go ahead and plug it in. So we've got a squared plus b squared equals c squared. Let's say a is our 24. B can be our x. Doesn't really make a difference which one goes where, just so long as the 24 and the x are on the left. The c, of course, is the hypotenuse. We know the hypotenuse is always the side that that 90 degree is pointing to there. So therefore, we know this is the hypotenuse. So that'll go on the right side. All right, don't be afraid to use a calculator, okay? 24 squared will end up giving you 576. 25 squared will end up giving us 625. Now this time our variable that we're solving for is on the left side along with this 576. So we're going to want to subtract 576 from both sides. When we go ahead and subtract these numbers, we should get 49. And when we square root both sides, that will give us 7 miles. Now again, when you look at a right triangle, remember that the hypotenuse is always the longer side. So the fact that we got something smaller than 25 is good, okay? If we had gotten something bigger than 25, we would have known that something must have been wrong, okay? So this is how we're gonna draw pictures, okay, to represent vectors, and then use the Pythagorean theorem to find the missing side. All right, the last thing we're gonna do today, okay, with our Pythagorean theorem is doing area and perimeter, okay? And we've done area and perimeter, obviously, a bunch of times, okay? But now what's gonna happen is we're gonna be missing a value, and we're gonna need to use the Pythagorean theorem to find that missing value in order to then be able to complete the area and or perimeter, okay? So just as a quick recall, guys, perimeter is the distance around a figure. Therefore, to find the perimeter of any figure, simply add all the sides together. Now, I know that certain shapes have formulas to find the perimeter, and if you know them, awesome. But really, guys, perimeter is just adding up all the sides, so don't be afraid to just do that. And then, of course, area is the space inside. All right, so this is what I mean by needing the Pythagorean theorem. Because the first thing I want here, guys, or I should say for number 3, notice it's a rectangle, okay? Well, if I wanted to add up all the sides, the problem is I only have this side so far. And because it's a rectangle, I do know that this will also be a 5. But if I want the perimeter, I'm also going to need the top and the bottom. But all they've given me is the length of the diagonal inside. So again, even though I'm looking for the perimeter and area of a rectangle, let's see if I can break it down into a right triangle to at least find something to help me with that. If you notice, guys, this diagonal breaks up this rectangle into 2 right triangles. So let's kind of just focus on this right triangle that I've highlighted on the bottom, kind of ignore this guy right here. And notice that all we have is a right triangle where we have one leg, we have the hypotenuse, and we just need to go ahead and find that other's leg. Okay, so we're gonna just go ahead and pop this guy out there. We're gonna plug into the Pythagorean theorem. A squared plus b squared equals c squared. So the 5 and the x are the legs, so we'll go 5 squared plus x squared equals 13 squared. And then go ahead and do our math. So we're gonna have to do 25. And on this side, that'll give us 169. Subtract the 25 from both sides. We gotta get the x squared alone first before we can square root. So that'll give us x squared equals 144. Go ahead and square root to get the x by itself. And that will give us 12. So what we've just figured out here, guys, is that the top and the bottom of this rectangle, well, they're just 12 inches. So now I have everything I need, okay? In fact, over on the side here, guys, I'm just gonna redraw this rectangle without that line in the middle so you can really see what's going on here. All we have is this rectangle. The sides are 5 and 5, 12 and 12. So the perimeter, again, is just adding them all up. 5 plus 12 plus 5 plus 12. Notice it's just 2 5s, which is 10, 2 12s, which is 24. It's just going to give us 34 inches. So the perimeter is 34 inches. As far as the area is concerned, we should remember this formula, but it's length times width for the area of a rectangle. And when we go ahead and plug those numbers in, 12 times 5, we're just going to go ahead and get a 60. So our area is 60, and because it's area, we put that little inches squared there. So again, this is no different from what we've done before, except we had to do the Pythagorean theorem so we could find this side length here. Then we had everything we needed to find the perimeter and the area of the rectangle. We're just going to do a few more, okay, just with different shapes so that way you have in your notes all the different formulas or procedures that you may need, okay? So for number 4, we're talking about a triangle, okay? Let me just shade over that height there so everybody can see that better. So for number 4, we've got a triangle. Notice that right now, we already have all of the sides for the triangle. So as far as the perimeter is concerned, we already have all the stuff we need. It's a 10 plus 10 plus 16. It's going to give us 36. Okay, so for the perimeter, we're good to go. It's really just the area where we're going to have to do a little bit extra work. Because remember that the area of a triangle is half base times height. So yes, I've got my base here, okay? This is going to be my base, remember from unit 7, okay? My height is going to be that line right there. Remember that the height of a triangle starts at the top and it goes perpendicular to the base. So basically the idea here is let's go ahead and find out what that height is by just concentrating on half of the figure, kind of what we did for number 3. So we're going to focus on just this triangle right here in order to get us our height, which will then allow us to find the area of the big triangle. Now something that we should know, okay, that I don't think we've talked too much about, but notice that these are both 10. So if this whole entire base is 16, because this is an isosceles triangle, guys, this height is going to break that 16 up into 2 eighths. So when we go ahead and do the Pythagorean theorem on this tiny little triangle, it's going to be a 10 on the slanted part, an 8 on the bottom, and then of course we're solving for our h on the side there. Okay, now I'm sure a lot of you guys probably would have just done that because it looked right, but just to tell you, you are right, okay? Because this is isosceles, this height actually comes down and breaks this up in half. So this is what we're using for our Pythagorean theorem. So again, that's a squared plus b squared equals c squared. Our a and b are the legs, meaning the two sides that make up the 90. So that'll be h squared plus 8 squared. And then the hypotenuse, which is the c, is this slanted guy right here, the one that's across from the 90 degree. So that'll be 8 squared plus 64 equals 100. Subtract the 64 from both sides. That gives us h squared equals 36. And when we square root, that'll give us 6. Okay, so now what we just figured out is that our height back in this original triangle here is 6. So now that we're looking to find our area of the entire thing, okay, we just need to go ahead and do 1/2 the base, which is the 16, times the height we just found, which was the 6. So we're going to do 1/2 16 times 6. Grab a calculator, put it all in right away, do half of the 16, then times by 6. Whatever works for you guys. We talked about a lot of different ways back in Unit 7, but what you should end up with is 48. Now again, this right here is for the entire triangle. Okay, so I went back to using the 16 for the base because I wanted the entire triangle that I highlighted in blue there. Okay, so we just had to use the Pythagorean theorem with half of this triangle so I could figure out the height, and then we went back to using the entire thing. All right, and lastly, what if we have a square? Now, next section of notes, guys, we're going to talk about some tricks with squares and shapes that have, you know, like 45 and 90 degree angles and 30s and 60s. But right now, I just want to show you what we can do with the Pythagorean theorem. So we've got a square. I know it's a square because we've got all these tick marks along the outside here. And I know that the diagonal inside is 4. However, that's not really going to help me with my perimeter and area because I need to know the outside lengths, not the inside. But now again, referring to what we had done up here for 3 and 4, we're going to focus on just half the shape. So if I look at just half the shape here, and again, I realize I just did the top, I could have done the bottom, whatever works. But basically what's happening is these two sides are the exact same thing. So I'm just going to call them X and X. And then of course we've got the diagonal here, which is going to end up being our hypotenuse. So when we go ahead and again plug into our Pythagorean theorem, a squared plus b squared equals c squared, that's just going to be x squared plus x squared equals 4 squared. 2x squares, well, that's just 2x squared equals 16. We're going to have to divide by 2 first to get our x squared alone. And then lastly, we're going to go ahead and square root this. All right, this is not going to be pretty. But just like we were doing before, let's just go ahead and round it for now until we learn a little bit more of what to do with these. Okay, so when we square root 8, all right, we're going to take it to 2 decimal places. We will get 2.83. So we're getting 2.83 around the entire side. So 2.83, 2.83, 2.83, 2.83, all around. So to find that perimeter, we're just adding all of those 2.83s up. Or all you really need to do is, since they're all the same amount, we can do 2.83 times 4. 2.83 times 4. And that's going to give us 11.32. Oh, sorry, that's our perimeter. So for our perimeter, we've got 11.32. As far as our area is concerned, that's length times width. So 2.83 times 2.83. And that gives us 8.0, technically 1. But I'm going to tell you the truth, guys. It's actually just going to end up giving us exactly 8. So we've got 8 centimeters squared. So look how tiny that little decimal is. For our perimeter, 11.32. Okay, and that's what gives us our square. Now I've uploaded some homework problems. Okay, although it is not required that you submit them, it is highly recommended that you do them. Okay, we'll have another video up after spring break. Same thing with homework, recommended you do it, okay? And then we will go ahead and assign a Google Classroom quiz based on the last 2 sections of notes. If you have any questions, make sure you let me know. And of course, highly recommend to do the homework even though it's not being submitted, okay? Have fun and let me know if you have any questions.